As you said, I'm from Open Robotics. I have a background in mechanical engineering, and I work on physics for Gazebo. Sometimes, so I have to be careful when I say that, because there's some issues sometimes, but there were no projectiles today, so that's good. I'm going to talk about just kind of the latest things at Open Robotics. The two latest releases are ROS2 Eloquent and Ignition Citadel. Now, I made this presentation within Gazebo, but I recorded it because otherwise it wouldn't work on the live stream. It's using a package called SimSlides that my colleague Louise Pubel, or Chapulina, created. So it's kind of fun. Hopefully it's not too much of a distraction. But so, yeah, I'll start by talking a little bit about Open Robotics, and then ROS2, Gazebo, and Ignition. Just a huge constellation of things. And also bridges. There's going to be some bridges in here. So just a little bit about Open Robotics. What we do, we create open software and hardware platforms for robotics. And we use those platforms to solve important problems and help others to do the same. We are about 40 people spread out across the world, roughly half in our Mountain View headquarters, another quarter roughly in our Singapore office, and the rest working remotely in various places, including 3 in Spain for the Europeans present. So we make, so I think of robots as computers that move. You know, any motion, any action that they do, there's software behind it. And anyone who's used a computer has probably seen it not work properly. So that inspires kind of the two software projects that we work on. So we have ROS, which is an application software development kit. You use it to write software that you install on the robot to make it operate. But you need to test it because it's probably not going to work right on the first try. So that's why we have simulators. First Gazebo and now Ignition. And that lets you develop and test your robot software. Hopefully you can test it safer and more cheaply and more quickly. There's also work done by our Singapore team that I'm not going to talk about, but Eric, I believe, will talk about that some tomorrow. And it was also discussed at ROSCON. As soon as the videos from ROSCON go up, you can see that as well. And so we kind of fly over to this other island. Let's talk a little bit about ROS-I as the waves kind of wash onto the beach. You know, we've come a long way with ROS-I since it reached 1.0 status with the PR2. The community has grown. ROSCON, is bigger and bigger each year. There's products on the market that use ROS that people can buy for logistics and other things. Companies that use ROS are receiving investment, and this is, and our latest release of ROS-I is ROS Melodic. It's a long-term support release, LTS. It was released last May, so 2018 to 2023, aligning with the Ubuntu long-term support releases. But it uses Python 2 in a lot of its packages and dependencies. But Python 2 will not be maintained after January 1st, 2020. So this kind of is motivating some migration work that we'll be doing. Just before I describe that, I believe Ubuntu will continue to support any software that is in one of its long-term support releases. So I wouldn't freak out about Ubuntu Bionic and ROS Melodic. Those will continue to be supported by Ubuntu, is my understanding. But because of this change, we have another ROS1 release planned for May of 2020, ROS Noetic, and this will include a full migration to Python 3. So any packages that depended on a Python Ubuntu package will now depend on the Python 3 Ubuntu package. So this will mean people need to migrate their software that's using Python 2. And there are guidelines for how to do that on the wiki on a page called Using Python 3, I think. That sounds right. And there was also some discussion in the lead up to the announcement of this release of ROS Noetic. Will this be the last ROS1 distribution? That's an open question, but there's a lot of time till 2025, so we'll see. But one of the reasons, that's a pertinent question is that the next generation, ROS2 TNG, has been making a lot of progress. No Star Trek jokes? Okay, that's fine. So ROS1 was great at a lot of things, but there were a few places where it had some room for improvement, and those motivated some of these goals for ROS2. Improving the quality of some of the design and implementation, reliability, real-time determinism, being able to validate, verify, certify, giving more flexibility in communication protocols, and embedded support. And we've seen a fair bit of progress on, and that motivated some architectural changes. And as I said, ROS1 did some things really well. One of the great things it did was it had a really nice user interface, that purple layer on top of the stack. Really easy for people to learn, and that contributed to its growth. And so the goal was to keep that simplicity, to still have that friendly purple layer on top, but to kind of improve the layers underneath. And so part of the new architecture design is to use DDS, which is an industry standard. There's multiple implementations. Connects, FastRTPS, and OpenSplice are some of the ones we support. And then adding these layers, the robot middleware RMW interface. So that is the only thing that has to talk DDS. And then on top of that is a C library, the ROS client library, and that's the one that talks to RMW. And then to have better support for client libraries in languages that have better support for the idioms of those languages, you build on top of RCL. So you have RCL CPP, RCL Pi, RCL Java. And then based on some of the security features built into DDS, and also just kind of this improved layering, it's really improved the architecture while still keeping that nice user interface on top. And Windows is in there too. Thank you, Microsoft. And there's been some work using DDS in an embedded context. So people are already putting this new architecture to work with micro-ROS. Using it for Nobility, Matt Hansen spoke earlier today about the nav stack at Intel. And also at ClearPath, this quote says it's from 2018. and that they had been using ROS2 in production critical systems for nearly 3 months. So if that date is right, that's over a year. So people are using it. In automotive contexts, if you're going to use ROS for something beyond telematics or just kind of entertainment, if it's going to have any safety consequences for driving the vehicle, determinism and safety and certification are really important. And the AutoWare project and Apex.ai are both groups looking at that. There's also a great technical steering committee who help plan the work, but also help do the work. So thanks to all the companies who participate that and contribute to it, and the whole ROS2 community. And ROS2 has an LTS release. It was released in May, and it'll go to 2021. It has actions, better Python support, Move It 2, diagnostics, ARM-HF, and pretty cool one is Composable Nodes. I'll come back to that in 2 slides. And just not even a month ago, we released Eloquent, which will go until, there's a typo, that's November 2021. It's actually 2020. This isn't an LTS. But this has launch files using the familiar XML format. Yeah, a lot of good stuff. But I'll just talk really quick about the composable nodes, because this is an improvement to the API. There's like the whole node versus nodelet discussion, and if you wanted to have like if you had an image pipeline and you wanted to separate things into nodes for just kind of logical clarity, it would serialize between all those node communications, but you would use a nodelet and it would communicate faster using intra-process or using shared memory. But now you can get that, you can have that flexibility with performance by using composable nodes. There was another talk at ROSCON about that. I recommend it. It's pretty cool. Also, an RMW implementation that can do zero copy, and a bridge. A really helpful part of migration is being able to upgrade your system bits at a time. So, one node at a time or whatever. And you can use a bridge. So if you start using the ROS2 nav stack, but you're still using something else from ROS1, your system can still function. Yeah, big on metaphors, I guess. Now let's talk about Gazebo a little bit. The goal for Gazebo is to be the best possible stand-in for a real robot. It should do physics, sensing, be extensible, and interface with ROS. What did I just do? Sorry. Boop. So first, talk a little bit about physics, which is my specialty. And there's a lot of different physics engines. Gazebo has an abstraction layer that interfaces with different physics engines, so you can choose the best one for a given situation, because we haven't really found one that's universally better in all cases. But we give a common standard API on top of that, similar to it's a useful abstraction layer. But you can choose your engine at runtime. And there's a lot of different features of the different engines, like maximal versus reduced coordinates. I had the simulation paused. I'm unpausing it. And now you can see there's a pendulum swinging, and there's a PR2 with its sensors. It has a camera sensor. You can see a little tiny rendering of what the PR2 sees, and it sees the pendulum, and then it has a LiDAR scan that's visualized down there. So we provide different lot of different sensor types with noise models. You can also see kind of a noisy camera image, kind of got the salt and pepper noise on it. And we also, similar to the physics abstraction layer, there's a rendering abstraction layer, so you can choose between different rendering engines. And it's also extensible, has a plugin API, so you can do controllers, or you can add your own custom noise models. But one of the most useful sets of plugins that we have is the Gazebo ROS plugins, which is the next slide after this. This is just a summary of the Gazebo versions that we have. There's 2 LTSs currently running, and in January we're planning to release another LTS, Gazebo 11. But as I said, one of the most useful plugins that we have is for interfacing with ROS. This is Gazebo ROS packages. So this will translate topics in Gazebo's transport layer to ROS topics. And you can also call ROS services via C++ API. Or you can, yeah, in Gazebo. And that's basically a bridge. I put like 5 bridges in this thing. It's get past that real fast, but it's working with ROS2 as well. So you can go from Gazebo to ROS2 just like you do Gazebo to ROS. And Gazebo is great, but it has issues as well. It's a monolith. It's all compiled together, so it's hard if you want to just use like the sensor models somewhere else. You know, it's hard to do that because you'd have to have Qt so you can build the GUI because it's all in the same package. So we decided to explode it into lots of little packages that we call Ignition Robotics. And this includes like Ignition Math, Ignition GUI, Ignition Messages, Ignition Physics. And we've tried to really isolate the functionality and dependencies so it could be shared in different applications. I'll talk a little bit about Ignition Physics. So we just flew back to the Gazebo island just to remember how we select a physics engine in Gazebo 9. And the way that works is it has to find it at configuration time. So if you want to add a new physics engine, you have to rebuild Gazebo. That's not ideal. Or if you have the Ubuntu version of Gazebo, even though Gazebo supports Dart, it's a great physics engine, Dart isn't in Ubuntu yet. It will be in Ubuntu F next year, but it's not in Ubuntu Bionic. So even though the Gazebo source code supports it, the deb was built without it, so you can't use Dart unless you recompile from source. So that's kind of inconvenient. So we said, let's make them plugins. So then at runtime, you can just, use a different physics engine if it's available. You don't have to rebuild everything. And one of the other really cool things that we did with that is we made this feature, this really flexible feature concept. So when you make a plugin, a physics implementation plugin, which will provide Dart or Bullet or Open Dynamics Engine or Box2D or PhysX or maybe you wrote your own soft body simulator. You just declare, you write a definition of a feature that has a specific API, and then you implement that API in your plugin. And then on the user side, you just request the features that you want. And if you say, I need a physics engine that has Steve's soft body thing, it's probably not going to be in things that aren't Steve's physics engine, but it lets users create their own features. Because with Gazebo kind of had this lowest common denominator issue with features. So, sorry, it's just a bunch of like code on there. I think it is cool though. We only have one implementation so far for Dart. It won't really be proven until we have multiple implementations, but we're working on it. We've made some improvements to ignition rendering. It's using physically based rendering, which is really neat. There was a talk at ROSCON about that by our 3D artist Cole. This is just a screenshot of Gazebo, Ignition Gazebo, the new version. It has, it looks a little different, but it has a lot of the same, interface. And we made a release of Ignition Blueprint in May that has physically based rendering. We're working on distributed simulation so that you can, if you have a very large environment with multiple robots, to try to partition that up into multiple CPUs to try to make it go faster. That's still a work in progress. And today, people have been releasing packages for Ignition Citadel. I think tomorrow will be the official announcement. But this adds actors to Ignition Gazebo. It adds a thermal camera, visual markers, and new frame semantics for SD format. We added a new attribute to the pose tag called relative2, and this makes it a little easier to specify, to define certain types of models. So if you'll notice the pink arrows in that diagram, there's two links. There's a base and a pendulum link. But the pose of both of those is specified relative to the model, even though it's really a series, like a recursive chain. And that's just that's how SD format 1.6 works. URDF is a little bit different. And what I've illustrated in the background is a double pendulum where if you were using the SD format pose approach, but then you said, oh, I want the pendulum to be lower. And you think, I just need to lower that upper link, the first one. Well, in 1.6, it'll only lower that one, and the other one will be disconnected. And that's not what you really wanted. URDF would handle it, but now you can do that in SD format 1.7 using the relative2 tag. You put the name of the frame that you want it to be relative to. There was a talk at ROSCON about this as well. And there's two bridges in the background of this slide because ROS-I, so Ignition has its own transport protocol that uses 0MQ and protobuf, and you can bridge that to ROS1 or to ROS2 using the ROS IGN bridge. So that is a quick summary of what we have going on at Open Robotics in 2020. And just want to thank all the people who helped me put this presentation together. Thank you.
Thank you, Steve. Do you have questions for Steve? Matt, please.
So I'm a little confused. There's Ignition Gazebo and there's Gazebo Classic.
Yep.
Monolithic or whatever. At some point, does Ignition Gazebo then replace the monolithic version? And is there a timeline for that?
So there's not a timeline yet. We do have another LTS. The Gazebo 11 LTS will be in May, going to 2025, And all of our new development effort is going towards ignition. We're still trying to get it, we're still trying to get it up, get the features up to be comparable. So it is kind of a ROS-1, ROS-2, but it's a bit earlier than where ROS-2 is currently at. I think it is intended to replace Gazebo Classic, but there isn't a timeline yet for that.
Okay, thank you. Any other questions? Then I would say thank you again for the nice presentation.
Okay, thanks.